Hello students, today we'll start from spherical lenses numericals. So before starting this numericals, we will look for some sign conventions. The first topic is sign convention. अब बेसिकली हमें इसमें जरूरत क्यों पड़ती है साइन कन्वेंशंस की, ताकि हम अपना जो न्यूमेरिकल्स हम लगाएंगे उसका एक एग्जैक्ट वैल्यू हम एग्जैक्ट आंसर हम निकाल लें. वी नो कि जो फॉर्मूला हम यूज करते हैं लेंसेज के लिए दैट इज 1/f is equal to 1 by v minus 1 by u. The main thing we have to remember before using this formula that we have to put the proper signs of these variables, that is u, v, f, focal length, image position and object position. So first, rule number 1, we have a concave lens. Let us suppose this is a convex lens and this is optical center. Let us suppose this is our origin, we can also say, because we know for the coordinate systems this is 0 0, that is origin, and all the values in this side are positive, and all the direction in this direction, that is this one, all positive, and in this direction also negative, and on this axis these are negative. So similarly we can use this rule here, that is, let us suppose we are here and all the calculation, that is v, f, u, are made from this point, that is optical center. This is optical center and all the calculations are made from this point. Now let us suppose this is convex lens and we know the focus is in this direction, so all the values here will be taken as positive, and all the values, this is origin, this is positive side, this is negative side, means all the values in this direction are negative, and in this direction also negative downward, and in this direction also, that is positive. Now let us suppose the focal length, I give the radius, the center of curvature, the distance from the optical center, this one, this is the principal axis and this is focus. Now I give that this distance from here to here is 10 centimeter. Let us suppose. Now I am to identify what is the focal length, and I have given this as focus. The focal length will be given like this. I am to start from here and in this direction to the origin, means all the calculation in this direction are made positive. So this is plus 10 centimeter. If I make a convex lens, this is concave lens, and I say the object, the focal length is here, and I am to calculate the values from this point. So the f, that is focal length, will be negative, that is 10 centimeter minus 10 centimeter, because the object is, the focus is in this direction, that is negative focus. Similarly, if I place an object here, second, this is a convex lens. If I put the object at this point, means I am to calculate this position. This is 10 centimeter, means the object is placed at 10 centimeter from mirror. So here the u will be 10 centimeter, but this is in this direction of the origin, or say optical center. So I have to put the sign, that is minus 10 centimeter, minus 10 centimeter. So this is the object distance. So these are the basic concept we have to use. So from here what we conclude? We conclude that for a concave lens and here convex lens, u is always negative and f is always also negative. But in the case of convex lens, u will be always negative and f, that is focal length, will be positive. Why? Because all the calculations are made in this direction and the focus of the convex lens is here, means this distance is taken as positive values. So all these calculations made in positive values. Now, if you do some questions by using this concept, the main things is the numerical values, the variable or say the coefficient whose numerical value is given, we have to use only those sign convention. Let us look for a question. Write a question. Let us suppose we have a convex lens having focal length 10 centimeter, and an object is placed at 20 centimeter from convex lens. Calculate the position of image. What we do? Firstly, we go for its solution. So make the convex lens. This is convex lens and this is optical center. Means here this is the principal axis. Now what is the question saying? Question is asking that we have a convex lens, means we have developed a convex lens. Now focal length of 10 centimeter, and we know the focal length of the convex lens is directing in this direction, means focal length is here. So this distance is 10 centimeter and an object is placed at 20 centimeter from convex lens, and object is always placed in the front of lens. So the object is placed here, let us suppose, and this distance is given as 20 centimeter. Now from the calculations, we have u is 20 centimeter, f is 10 centimeter, we have to determine. If I directly put this value in the question, so I have the formula 1 by f 1 by v minus 1 by u. If I put the values and find the answer, then what will this? 1 by 10 is equal to 1 by v. We have to identify, we have to calculate, and this is 20. Then 1 by v will equal to 1 by 10 plus 1 by 20, and this is 20 LCM. And how much? 2 plus 1 means v will be positive 20 by 3. By calculating all the values, we are happy that we have calculated the answer. But we have forget to use the sign convention. Then what to do? The actual approach to solve this question is this, that firstly put the actual sign. So here we have u, means the u is in this direction, so u will be taken as minus 20 centimeter by using sign convention, and focal length is in this direction, so it should be taken as plus 10 centimeter, and we do not know v, so we have to not use any sign convention for v, because we don't know what is v, what is the numerical value v. Now put the values in our formula, then we get 1 by f is equal to 1 by v minus 1 by u. What we get? We will get 1 by 10 is equal to 1 by how much? V minus 1 by minus 20. Calculate this value. 1 by v, 1 by 10. This and this will become positive, and in this direction it will go. Then 1 by 20. If I calculate, then 1 by v, this is 20, and 2 minus 1, that is 1 by 20. Then how much v? V will become 20 centimeter. And what is the sign of this? Positive. The sign of this object location is plus 20, means the object, the image of the object will be formed in this direction. In this direction, so we can say that the image location will be in this direction, and the position from here is 20 centimeter. Here the image will formed at 20 centimeter and in inverted sign. So this distance is 20 centimeter. And simply we can also that at the center of curvature the object, this object A, B, image will be formed at 20 centimeter. So by keeping these all calculations, these all ideas, we can easily calculate any question in our module or in any. Now the second variation in the question. Magnification of convex lens is 3 and focal length of lens is 10 centimeter. Calculate the position of image. So in the last class we study that magnification is given as V by U, this one, and we also know the lens formula is 1 by F, that is equal to 1 by V minus 1 by U. Here the magnification is given and we have to calculate the position of image. So we can write 3 is equal to V by U, and this is convex lens, so magnification will be negative, this one. So U will become V by 3 minus this one. Now put the value of U in our this basic formula. What is this? Focal length of the convex lens is given 10 centimeter, and we know the focal length of the convex lens is what we have calculated here, that is positive, means we can take 1 by how much? 10 is equal to 1 by V, and what is the value of U? That is minus of 3 by V, and this negative. So here it will become 1 by 10 is equal to 1 by V plus 3 by V. So on calculating, what you get? 1 by 10, that is equal to V 1 plus 3. So what will be V? V will be 40 centimeter. Means the object AB image will be formed at 40 centimeter. So this is all about our spherical lenses, and this is all about our light chapter.